question we will be working on today is FRQ3 from the 2012 AP Calculus exam, Form A. We will provide the graph on the board as we work the problem for you. Read the information given to you carefully before beginning the problem, taking time to process it. Notice that in the introduction they give you the relationship of g of x to f of t. Circle this and keep it in mind, as it will likely be useful in solving the problem. Part A says to find the values of g of 2 and g of negative 2. First, let's take a look at the relationship that was provided to us. G of x is equal to the integral of f of t from 1 to x. Since we are solving for the values of g of 2 and g of negative 2, we will plug in the numbers into this equation to find our answers. Let's begin with g of 2. G of 2 is equal to the integral of f of t from 1 to 2. Knowing that a definite integral implies that you're looking for the area under the curve between these limits, look for the area under the curve from 1 to 2. Seeing that the shape is a triangle, this should lead you to the formula of area equals half the base by the height. Pause the video at this time and try and solve for the area for yourself. Our base is 1 and our height is negative 1/2. This gives the answer negative 1/4. Remember to keep the height negative in this case because it is under the x-axis. This is a common error for students. Let's take a look at g of negative 2. Following the same process as we did previously, this means that we are looking for the area under the curve from 1 to negative 2. However, this provides an error because, as we know from the integral rule, the integral of f of x from a to b is equal to the negative integral of f of x from b to a. We should remember that the smaller number needs to be in the lower limit of the integral. In this case, it is in the upper limit, so we need to flip the limits and negate the integral. This means that we are now solving for the area under the curve from negative 2 to 1. Split the area into parts. First, we need to see that a triangle shape is from negative 2 to negative 1. So we can use area equals half the base times the height for this portion of the area. Pause the video on your own. As you can see, this gives us 1/2 times 1 times 3. Which equals 3/2. The next shape we see is a semicircle, so we will use the area of a semicircle equation, pi r squared over 2. Once again, try to solve this on your own at this time. Our radius is this distance from the center to one side of the circle, which is 1 in this case. This gives us pi over 2. Now we add these two areas together, yielding 3/2 plus pi over 2. Now here you could simplify and combine to make them 3 plus pi over 2, but we suggest stopping in any AP problem once your answer is in terms of numbers. Anytime you simplify, you risk making an error and losing all credit on the problem, so you can just stop
Part B asks you to find the values of g prime of negative 3 and g prime of negative 3, or think it doesn't exist.
Part B asks you to find the values of g prime of negative 3 and the second derivative of g of negative 3. or state that it does not exist. To complete this part, you must understand the relationship between f and g.
G of x.
Recall the fundamental theorem of calculus to relate these variables. With the information given in this problem, we know that g of x is equal to the integral of f of t from 1 to x. According to the fundamental theorem, g of x equals f of b minus f of a. So with the original problem, g of x equals f of x minus f of 1. Take the derivative to find the value of g prime of x, which is g prime of x is equal to f of x minus 0, or g prime of x is equal to f of x. Now we have the relationship between g prime of f to solve for g prime of negative 3. Another way to recall this is that the derivative of the integral of f of t from c to x is equal to f of x. To find the relationship of f and the second derivative of g, take the derivative again, yielding the second derivative of g of x equals the derivative of f of x. So shorthand, we can use the fundamental theorem to show that g prime of x equals f of x, and the derivative of this can be taken to see that the second derivative of g of x equals f prime of x. To find g prime of negative 3, we find on the graph f of negative 3. We can see that f of negative 3 equals 2, so we can conclude that g prime of negative 3 equals 2 as well. To find the second derivative of g of negative 3,
Okay, using this technique
of f
to find the slope,
you must
we find
understand
out the
that
answer
the
is
derivative
1.
means slope.
Therefore, G
With this
prime
knowledge, we
of
can find that the slope of the graph at x equals negative 3, using the rise over run technique. Pause the video now to see if you can find the slope on your own. Using this technique, you can find that the slope is 1. Therefore, the second derivative of g of negative 3 equals 1, because the second derivative of g of negative 3 equals f prime of negative 3. Part C asks you to find the x-coordinates of each point at which the graph of g has a horizontal tangent line. For each of these points, it wants you to find if g would have a relative max, min, or neither at the point. Justify your answers. Let's start by taking a look at the first part of the question. Find the x-coordinates where g, not f, which is the graph given on the front page, has a horizontal tangent line. To remember the relationship with g and f that we just talked about, I suggest rewriting it at the top of the problem. G prime of x equals f of x, and the second derivative of g of x equals f prime of x. Okay, so for the horizontal tangent line, recall that this occurs when the slope is equal to 0. So in this problem, we are looking for when g prime of x, or the slope of g, is equal to 0. Since all we have is the graph of f, we must think about the relationship between g and f to solve for this. G prime of x equals f of x. So we are looking for where g prime of x equals 0. Therefore, we are looking for where f of x equals 0 on the graph. F of x equals 0 on the graph when a 0 occurs. Take a look at the graph and mark where you think this occurs. Pause the video at this time to do your work. Our next task is to see if g has a relative max or
Looking
min,
at the graph,
or neither,
we see that this
at
occurs
these
at x equals 1
So
and
where do
x
you
equals
see a
negative
max or
1.
min?
Our next task is to see if g has a relative max or min or neither at these x-coordinates. So where do you see a max or min in calculus? Maximums occur when the slope of a graph changes sign from positive to negative. Minimums occur when the slope of a graph changes sign from negative to positive. In this case, we are looking for where the slope of g, or g prime of x, changes sign in these ways. Remember, g prime of x equals f of x. So on the graph of f given, we are looking for where f of x changes sign, or where it crosses the x-axis. Take a look at x equals 1 and x equals negative 1, and see what you can find. Pause the video at this time and try to work this out on your own. Let's take a look at x equals 1. At this point, the graph does not cross the x-axis, and f of x does not change sign. This means that neither a max or a min occurs at this point, so it would be neither. At x equals -1, the graph goes from above the x-axis to below the x-axis, and the sign changes from positive to negative. Since the graph changes from positive to negative, a maximum occurs. Remember that the instructions say to justify your answers. A suitable explanation on the AP exam would be as follows. The graph of g has a horizontal tangent line, where g prime of x is equal to f of x, which is equal to 0. This occurs at x equals -1 and x equals 1. G prime of x changes sign from positive to negative at x equals -1. Therefore, g has a relative maximum at x equals -1.
Part D involves
G prime
finding
of
the points
x
of
does not
inflection on
change
the graph.
sign at x equals
Points of
1.
inflection occur
Therefore,
when the second
g
derivative
has
of g
neither
of
a
x
relative
changes
maximum
sign.
nor a relative
Since we know
minimum
that
at
g
x
double
equals
prime
1.
of x.
Part D involves finding the points of inflection on the graph. Points of inflection occur when the second derivative of g of x changes sign. Since we know that the second derivative of g of x equals f prime of x, we are looking for where the derivative of f of x changes sign. We do this by looking where the function changes from decreasing to increasing or vice versa. It is helpful to label where the slope is negative and positive on the graph at this point. Pause the video and try for yourself. By looking at this, it can be found that the points of inflection occur at -2, 0, and 1. This is because the second derivative of g of x, or f prime of x, changes sign at these points. Remember to pay attention to the instructions and justify your answer. You can justify your answer with explanations given for this problem. Here is a suitable justification according to College Board. The graph of g has a point of inflection at x equals -2, x equals 0, and x equals 1.
We hope that the work we provided for this
Because the
problem
second
helps you to
derivative
understand
of
the
g of
topic
x
better. Thank you
equals
for watching our
f prime
video,
of
and we
x
wish you luck on your
changes
upcoming
sign
AP
at
exam.
each of these values. We hope that the work we provided for this problem helped you to understand this topic better. Thank you for watching our video, and we wish you luck on your upcoming AP exam.